So storing profiles, in fact, the previous video also talked about this, designing Instagram. There was a lot of jargon that a lot of you felt was there. Storing images has only one important question in it, all right? And that is, how are you going to store images? So there's going to be a lot of images. As you can see, number of active users are large. Per user, you have about 5 images, which is still a constant factor of the number of active users. And the question of how are you going to store these images is something which has been debated for a really long time in the whole technical field that we are in, computer science. And that is whether you want to store the images as a file or you want to store the images as a blob. Okay, so blob is a binary large object. And those of you who don't know about this, get back to your database classes, because this is something which is taught in engineering. There's also another one which is CLOB, character large object, and that's entirely useless, so ignore that. We are going to be having the argument of file versus blob. So images typically are large in size, and you can't store it as a varchar or something. That's the reason why you have a binary large object, which is specifically for large objects in databases. Now, you might think that databases have definitely got a lot more to offer when it comes to specialized storage compared to files. But my argument is not really, because the only few extra guarantees that a database gives you are mutability. Okay, you can easily mutate the rows in that database, basically one data entry. The second one is transaction guarantees. So transaction guarantees. The third one is indexes. Okay, so indexes are mainly to improve your search capabilities, right? Let's start with mutability. Are you ever going to be changing the image? You could, yes, but why would you ever want to do that? Why not just create a separate file? Because an update to an image is not going to be just a few bits. So it's going to be the entire image, basically. Why not store that in a separate file and get rid of mutability, make it immutable? So this is an unnecessary feature that the database is giving us. The second thing is transaction properties. So transaction properties are again not required by an image, because you're not going to be doing an atomic operation on the image. So you can get rid of this. There's another feature, actually, I better note that down. So that will be the fourth feature which is required, and that is access control. So yeah, let's get to the third one again. Indexes. Indexes are good for searching. They allow your data to be sorted according to a particular field. Let us say you have a profile table in that the name can be indexed. So anyone who's searching for Gaurav will find that entry quickly because it binary searches on the name. So for a binary large object, that's useless because you're never going to be searching on the content of the file. That's going to be ones and zeros, right? So you can get rid of that. And finally, access control. This is very important. It's one of the arguments for databases using binary large objects, but I would say that you can get the same access control mechanisms using a file system, right? It is a little tedious maybe, but setting up a file system, a secure file system, is almost as tedious as setting up a secure database, so nearly equal. The good things about a file are that it's cheaper. That makes a big difference, storing files. The other things about files which are good are that they're built for this. They're built for storing a file, and an image is a literal file. So that's one good thing, but it's a little abstract. Instead, they are also faster in a way because they are storing large objects separately. And you can do that in a database using something called vertical partitioning, where the profile ID is going to be over here and the image ID is going to be over here, and then you're going to store the image somewhere else. But if you're doing that, then why not store it on a file, which is not just cheaper, it's also less likely to do a select star nightmare. So if you do a select star on this table, so instead go for the file system. It's going to take care of that. I mean, you won't do a by mistake select star on the address and the ID. Okay, this is a little bit of a flimsy argument, but it's still, in practical real life systems, select star is used a lot. So it's one of the good things. The third thing is that these are static, so you can easily build a CDN over this, content delivery network. You can read up on this maybe in the description below. You can just read up on it in general. Content delivery network allows fast access. One argument for databases, which are going to be storing the files, I mean, at the end of the day, your database is going to be storing all your data. So it has to have some reference, some address to your file. And that is going to be the file URL. All right, and this will be stored in the database. So we are going to have an image ID of image URL and the profile ID per image stored by user with profile ID in location so and so. Where are you going to store this image? This file URL, it's going to be in a distributed file system. Right. So your distributed file system is going to be handling requirement number 1. And that's how you argue for files versus blobs. Now, if your interviewer is really, really pushing you for blobs, you could take it. I mean, it's not going to really spoil your design. It's only that it's good to have these arguments with you when you're logically, talking about what would be better in an interview. But don't push too hard. If they say that blob is what I want, go for it.